Uh, Hello everyone. This is Rahul Khobrekar, and we will talk about SR policy and SRPC today. Uh, Before we starting, we'll try to go with a few basic of SRs, which will help us to, go through the SR policies and SRPC. So let's define the coverage first. So we will be touching upon the manual SR policies. We'll talk about the XTC, which is our path computation element. We will be talking about on-demand SR policies, which is PCC initiated. We'll be using XTC here, and the configuration template as we go further in the presentation. So considering we have a less time, 1.5 hours is not enough to cover everything. We are keeping way upgrade related topics, NSO use cases with PCs and Flex Algo out of this scope of this presentation. The assumptions are the folks should be familiar with IP, MPLS, and Ethernet access technology, segment routing, and the MPLS traffic engineering. MPLS traffic engineering, no direct relation, but we can compare the benefits of MPLS traffic engineering or segment routing traffic engineering with each other. So for that reason, we should know about the MPLS traffic engineering. So we have full pack agenda today. So we have, we'll start with the basic of segment routing. Okay, I'll be touching upon it for 5 to 10 minutes. Then we'll go over the segment routing policies. We'll touch upon manual SR policies, then XTC, the constraints like path disjointness. Then we'll touch upon dynamic segment routing policies using SRODN and few use cases from the customers. SR fundamentals. So basically we have a segment routing, okay, it's a source-based routing. And I think we had a very good and detailed session last time in Joy of Learning given by Krishna on the SR fundamentals, and it was too detailed. But I just wanted to cover a few basic things before we start. When we start about segment routing, we have to understand about the segment identifier, which are the seeds, right? So we have actually 4 types of seeds which we can use in the segment routing policies. One is node seed, which can be called as prefix seed. The other one is adjacency seed. The third one is binding seed, and the fourth one is Anika seed. I'll not touch upon Anika seed because again it will be the advanced thing for this presentation. So I'll be touching upon node seed, prefix seed, and adjacency seed and binding seed. So node seed is basically when you say the node seed itself is telling you it's representing a node. Okay, so this is derived from the sRGB block which you define in the configuration, and you have a prefix index configured. So with that combination, it is getting derived from there. So the advantages of having node seed is it's unique in entire network. Okay, so let's say here in this example, you have a router Z here, which has the node seed as 16,001. If packet is coming from A or anywhere from the network, the reachability to Z will be with the use of 16,001 label. So at the end, the packet injected from anywhere in the network, the top label will always be 16,001 to reach router Z. Okay. The next is adjacency label, adjacency seed. This is basically, locally significant. All interfaces running under ISIS or OSPF running segment routing will get this label automatically gets generated. Okay, and this is locally significant. The other router will not knows about these labels. The third thing is binding seed, which I'll touch upon little bit later because it has to be explained in proper way wherein segment routing policy will be used. So I'll touch on that little later.
So let's say that if we are not configuring segment routing policy, then we don't need binding seed. Let's say if I am just working on segment routing CI related part, then binding seed is needed.
Not required. So only in case of you have a SR policy. SR policy is basically, represent with binding seed. Once your SR policy is up, you will get this binding seed. So I'll touch on that a little bit later. So we'll talk about the basic of SR policy. So SR policy is very simple. You know, if you have to configure, it's very simple to configure. Unlike MPLS traffic engineering, it is automated, fully automated. When you talk about SR ODN stuff, you know, it's completely automated and it's very easy to scale. At the end of this presentation, we'll come to know why it is very simple and automated and scalable. So the main advantages of having a segment routing policy is we don't have to maintain the state in the core. Okay, like we needed to, you know, maintain it into MPLS traffic engineering. You have head end, you have midpoint, you have tail end. You know, you have to maintain the LSP on head end, you have to maintain it in midpoint and as well as on tail end. So here you don't have to maintain any policy on midpoint and the destination end. Okay. Okay, so there is no interface tunnel configuration. It will be just segment routing policy. All right. We have MPLS traffic engineering tunnel. Will have interface tunnel there. Okay, so if you talk about the SR ODN, okay, you don't need to configure any policy on head end. You just have to define the template, and the policy and its segment list will get pushed from the XTC. We'll touch on that little bit later when we go over the SRODN and XTC part. But this is what, you know, you don't have to do multiple configurations on head end. Okay, so it's completely automated steering when you talk about the SRODN. So mainly the use cases, if you see the deployment, the main use cases are all automated, you know, SRODN. Few customers are only going for, you know, manual SRT policies. All customers are going towards SRODN policies where, you know, the management of states and everything is not required. Okay. The other thing about the SR policies is very useful in case of multi-domain. Single domain, you will be, you know, able to maintain it, you know, configuration and, you know, the scalability, everything. But it gets difficult when you have a multi-domain. When I say multi-domain, it's IGP multi-instance. So for that, we use XR traffic controller, which is XTC, to compute the end-to-end path. You know, we'll go through the XTC in much detail. You know, we'll have somewhere around 7 to 8 slides only on XTC, where you'll understand why XTC is useful when we talk about the multi-domain. The binding seed, again, for the scale purpose, you know. Okay, I'll touch on binding seed little later in this presentation. Then you'll come to know how it will be useful when we talk about the scaling purpose. All right. So basically, the SR policy is actually identified with 3 tuples. You just have to maintain head end, color, and the endpoint. That's it. So on head end, you just have to mention the policy color and the endpoint. That's it. Head end is where you configure the SR policy, the manual SRT policy configuration, or for SRODN, you need to configure the template for SR policy. And the color it's a numerical representation of SRT policies. It is actually useful when you have a multiple SRT policies between same source and destination. So you can easily differentiate between 2 SR policies. So this is a numerical value. Endpoint is, you know, obviously it is destination of the SR policy. Okay, as I mentioned, at given head end, we have to just maintain the color and the endpoint. If you see this example, let's say the policy is starting on router 1 and endpoint is router 4. Then you can say that, you know, head end is 1, color is green, and endpoint is 4. So this only 3 tuples we maintain here. All right.
We can define it only as a numerical value, or we can have.
You can define only numerical values. All right. So talking about manual SR policies or SRODN based policies, we have to maintain 2 things. One thing is seed list and the automatically getting generated your binding set. So seed list is nothing but, you know your source, you know your destination. Now you want to steer your traffic and you have to give, you know, the seed list. like you give it in MPLS traffic engineering explicit path, right? So IP address 1, IP address 2, IP address 3, that way hop by hop, you have to maintain that in seed list. So, you know, first hop will have this label, second hop will have that label, and, you know, till the end point. So that is called as seed list, okay? Once your segment routing policy is up, the binding seed will get automatically generated. Now, binding seed is nothing but, you know, it is representing this entire seed list, okay? And the traffic will push to the binding seed, all right?
So binding seed is another label which represents the entire seed.
Correct. So it is nothing but, you know, it's binding your seed list, complete seed list. It is getting bind on the binding seed.
But other than that, how will the midpoints and the tail?
It's not required, right? Because see, I'm on head end. I just have to worry about my next label, correct?
Right.
So if I'm able to reach that label, that should be fine. You know, once the traffic is pushed.
But the next guy need to know the remaining set of labels, right?
Correct.
Should be,
No, it will be source driven, right? Completely source driven. So your top label, you know, will have label stack, right? So swapping will be done.
It has one label for each of the hops.
Yes, correct. Yeah, I'll explain you when I'll show you the example there.
Around one more.
Yeah.
Do we have constraints like RSVP, like bandwidth or the?
Okay, so constraint like bandwidth are currently not supported in SR policy. Okay, if you want that, you have to either use FlexAlgo or you have to go with the way the Nest protocol and everything, right? So you have to use that. UCMP.
You can specify the percentage bandwidth.
Weightage. You're talking about MPLS traffic engineering or SR policy? Yeah, I'll go on that. So that is, yeah, I'll cover that topic as well. Yeah, I'll cover that topic as well. All right. So talking about manual SR policy, we have a few components of SR policies, right? We have to enable IGP with segment routing capabilities. Then we need to, you know, enable traffic engineering router ID, which is called as TEID. Then we have a segment list, as I mentioned, you know, per hop you have to maintain that, right? So while generating SR policy configuration, you have to maintain that SR policy segment list. SR policy, obviously, you know, you have to mention the color and the destination, and again in that you have to define the explicit path which will be, you know, used for the seed list, segment list.
This policy is per service, like let's say L2 VPN or L3 VPN.
Yeah, you can have a multiple services under one policy also. Okay. When I'll talk about the use cases from the customer, there are few customers using multiple services under one SR policies. We can talk about that later. So in SR policy, we have to maintain policy name, color, endpoint, and then candidate paths. Candidate path is nothing but your explicit path in MPLS traffic engineering. And we have constraints like disjoint path and affinity. Disjoint path I'll take little bit later because I have to cover like a good amount of coverage in disjoint path because I have prepared like 3 to 4 slides on that. So we can talk about that later. Affinity is, you know, you just have to color the link and you can use it like exclude the same like MPLS traffic engineering. Yeah. So configuring IGP for SR policy. Okay. So let's take an example here for router ISS. You have to enable the segment routing MPLS here in the ISS, and you have to maintain this TEID, which is nothing but your MPLS traffic engineering router ID loopback 0. So these are the must configuration. Other than that, if you need the FRR less convergence time, then you can enable the TILFA and other stuff. All right. The same configuration goes for OSPF also. You have to enable segment routing under your OSPF, and then you have a MPLS traffic engineering router ID again, which is also called as TID.
So we have to enable the T process, MPLS traffic engineering.
MPLS traffic engineering is not required, but you need to configure MPLS traffic engineering router ID. So that will be used for, you know, as a source of your SR policy. All right. So configuring SR policy, you have to define the segment list first. So defining is it, it can be seen, right, over WebEx, or
Right.
Yeah, yeah.
it's clear, right?
Even
Yes, Rahul. Go ahead.
All right, if it is visible, then that's fine. So you have to define a segment list under segment routing traffic engineering. This is nothing but the same like you have under MPLS traffic engineering, you define the explicit path, right? So you have index 10 MPLS level 92002. These can be your node state, or this can be your adjacency state. Okay, so you can define that way.
So while defining, how do I know what is the node state? I mean, I need to know that.
Yeah, you need to know that what is your node state. Let's say you have a destination, or you have a next hop, right? You should know about the node state of that router. Then you can define it here.
But we cannot give like loopback DSL.
Yeah, you can give it. So that option is also there. So you can define a segment list in three ways. One is all states, or you can define like all IPs. These are the loopbacks, and you have a mix of labels and loopbacks, IPs. Okay.
When you give IP address, it automatically figures out what is the.
Okay. For that, you need to enable under router under IGP, you have to enable the distribute link state, because for getting that labels information, you need to know the topology. So the link state is extension of the IGP, wherein you get all this information. So for that reason, you need to enable distribute link state under your IGP. If you have IP address, otherwise it is not required. Once you have state, it's enough.
so one more thing, Rahul, in that first example, it can be adjacency seed also.
It can be adjacency seed also.
Adjacency seed is local to the router, right? When it comes.
So you can define it for the first hop, or you can define it. See, as long as your packet is reaching to the next hop knows what its adjacency seed is, which link it can be used.
Okay.
Okay. You have to define hop by hop, right? The second router will knows about its own adjacency set anyways.
So one question now, this seed is manually defined in terms of range or an absolute value?
Okay. So see, this is all depends on your configuration. In segment routing, you have something called as sRGB range, segment routing global block, right? You define it 16,000 to 24,000, for example. And then under loopback of IGP, where you're running SR, you can define the prefix index. Okay, let's say you have 1001 configured as prefix index, so it will take 161001. So that will be your seed for that node.
Because once you define it, if suppose the router reloaded, that wouldn't change the.
No, it will not change. It will be there, because you are defining it into, you are reserving it into your sRGB range.
Your adjacency set will change, right?
Adjacency seed can be changed.
Then
Yeah.
your policy is invalid, right?
Correct.
So that's a disadvantage.
Yeah, that is a disadvantage.
And like in MPLS, we even have a dynamic path also.
Yes, we have it. We have that option. I'm going to that detail as well. So this is where we configure the segment list. Okay.
What is the scale of this?
Actually, if you see, it all depends on your platform. How much seed depth it can go for it. So that is where the binding seed comes into picture. Okay, which can the platform like Freta is currently like it started supporting the label, a good amount of labels now, 10 plus or 12 labels. But initially it was supporting hardly 3 or 5 labels. In that case, you have to maintain as per platform limitation.
That will count the service label as well.
Correct. So when I say 3, it was basically with service it was 3, and without service something it was 5, something like that.
And we can skip certain hops in between, like a mix of
Yeah.
explicit and dynamic.
Correct. Because the advantage is the label will be same across your network. So you can define one label also directly for the destination. But in that case it will go with your IGP.
That will be like a dynamic.
Yeah, dynamic basically. That is a disadvantage of having just putting a direct label of the destination. Okay. So this part is clear, right? If you have IP address configured, you have to define the distribute link state under IGP. Okay, because it needs the topology information to derive that label from your IP address. So that can be done with the extension of IGP, which is link state.
Forwarding table.
Uh-huh.
I have only my local adjacency labels and on the prefixes, right?
Yeah.
For all the other prefixes that I learned externally.
Mm-hmm.
my IDP
For that, you need your segment routing mapping server.
mapping. But if it's not required, then that is not
Yeah,
needed in the
yeah.
table.
This is not related with mapping server, because you are running into the same domain. Okay, if you have multi-domain, then you have to use SRODN.
No, I was comparing with LDP. Like
Yeah.
every prefix in the IDP table will have a label.
Correct. In
Here we have not.
segment routing, it is not there because if suppose for example the prefix is getting learned from IGP, you have to define it via SRMS, right? So you will generate the label for those prefixes. Okay, so configuring SR policy, you have a segment routing, traffic engineering, you can define the policy and then you can define the color. Policy is also, number. You can define any number, okay? The color is also the number. You can define that number and you have an endpoint. Let's say that endpoint is somewhere like router 4 in this case. And you have a candidate path, okay? I'll define what is the use of that preference path later, okay? Once we go through the configuration in detail. So the candidate path is same like what you have an explicit path in your MPLS traffic engineering, okay? So you are defining here explicit segment list 1001. If you see the 1001, you are defined there, your seed list 1001 that I'm going to call here, okay? And the advantage of this is, you can define multiple explicit paths inside one candidate preference, okay? One candidate path of preference 100, right? So you can define multiple explicit paths here, okay? Let's say explicit path segment list 1000, 8 and 1018. You can define it here itself, okay? The advantage of having that, if you have candidate path with preference 100, you can distribute your load across this explicit path. Let's say you have an option of configuring weightage here. If you say the explicit path 1001 should take weightage of 60%, then it will take 60%, and others you can divide as you want. 10%, 20%, you can define over the explicit path. Yes, correct. This is what is UCMP. The other option is you can have a multiple preferences. Let's say you have preference 200. Once the preference 100 explicit path is not available, let's say the explicit path is invalid, it will switch over to the other preference. But if you have under preference 100, you have multiple explicit paths, it will actually first see the first explicit path, then go for the second explicit path, then go for the third explicit path, and then it will switch over to the next preference, okay? And you can define whatever explicit segment list you wanted to define there. The third option is dynamic, okay? What you were talking about, right? It's same like MPLS traffic engineering again. So verifying a segment routing policy. Once you have SR policy up, you can actually see that with show segment routing traffic engineering policy, and you just have to define the color 1001. Let's say in this example. You see here the color is there 1001, endpoint is there 10314. The name is automatically derived, depends on your configuration. So if you see here SRT color 1001, endpoint 10314. That is derived automatically with your configuration. Okay. The status and everything is there. Then you have a candidate path preference, which is 100. Okay. And name of your color, basically explicit path, sorry. And you have your seed list. If you see that 92,002 and 1,02,000 or 93,002, that is your seed list, whatever you define there in your explicit segment list. Okay. So for each and every segment list, it will actually validate the first hop first. So that is why you see there prefix seed. If you have their adjacency seed, it will show adjacency seed there. All right. And if you see the attribute, there is showing its banding state. So as soon as you have SRT policy up, you will see that banding state is getting created automatically. So that banding state is nothing but it's actually binding this all three states. Okay. Now how this binding state will be used for your scalability purposes, you have a big network, you have a MPLS traffic engineering in between somewhere, your platform is not capable of holding those many labels, you can easily replace these three labels with that one label. So your traffic will get pushed over that MPLS, segment routing policy. Do you get this? Or do you want me to explain again?
So, what does the
Yeah.
intermediate node know that,
Okay.
let's say 1,000, 10,000 was what you're supposed to get in, right? But you're getting USB 6.7. So
Okay. So as I mentioned, right, this segment routing policy.
Before that, can you please explain that binding seed again? It was
Okay.
clear that.
So binding seed is basically once you have your SR policy up, the binding seed will get generated automatically. Okay. This binding seed is nothing but the list of your seeds. It is binding your segment list completely. So this segment list can be represented with one seed, which is binding seed.
So every time binding seed will be getting created.
Yeah, for each and every policy, it will be different. Now coming back to Abhishek's question, now let's say you have a big network, okay? From router A to router say Z, you need one SR policy, okay? And in between, you have already SR policy between router, let's say K to P, okay? You can easily replace those hops with this binding seed in your segment list, so that the seed list will be getting short. Okay, once that packet or the packet gets reached to that router, he knows like what is that binding seed and what are the list of the seeds containing in that binding seed. So it will directly push the traffic over that segment routing policy.
So binding seed is propagated to.
No.
Well, actually, by
So that is what hop by hop. It's always hop by hop. Once you reach to your router, you know what that binding seed means. Correct?
it has a list of
Correct.
How did it get generated?
Correct.
So how does the other router, he's asking that question, how does the other router know that binding seed is 3067?
Okay. I'll again repeat. So basically, see, once you define this segment list, as I mentioned in earlier discussion also, right? So basically, if you give seed list, you have first hop which only gets verified. Am I able to reach to the first hop? Okay. After that, what seed it is there, I really don't care. It can be adjacency seed also, which is unknown to me. The same goes with the binding seed. Got it? Got it? Because adjacency seed is also local. Okay, locally significant. So I'm not sure what is that the next hop, seed is there. Got it? So in that case, we can define the binding seed there, and you can steer your traffic over that SR policy.
when you compare to the T, right? 1 minute, yeah. When you compare to the T, right? The binding seed, you can also relate it to the tunnel ID, right, which gets created.
You mean auto tunnel?
Auto tunnel ID, how it gets created. Right?
Yeah.
You can relate to the binding seed. You cannot directly.
No direct relation,
Yeah.
but
Because when you want to send a traffic to a particular tunnel on a extended route path, when you create a tunnel ID gets created. Similar to that, can we compare that binding seed?
not directly. Yeah. All right.
Sorry.
Yeah.
So Rahul, let's say that okay, we are having 10 router topology, for example, and we are having tunnel SR policy configured on some routers. So on all those routers, binding seeds will get created.
Correct.
But whether those binding seeds are going to propagate it to other routers
No,
or not?
no.
Then how, let's say that okay, tunnel is there from router 1 to router 10, and let's say that okay, he will be including binding seed or not in that particular.
No, it will not, right?
Not.
Yeah, it will not. It is just, see, once you are running the services over SRT, right, these services will push over this binding seed. Okay, so binding seed is just a representation of your SR policy.
Global to the router.
Yeah.
Other routers will not be knowing that which binding seed he has created. So it is of no use for other routers.
Correct.
But how does it conserve the levels? Because all these levels are still there, right?
No, but you see, let's say I'm a head end. Okay, my capability is holding hardly 5 labels. So I don't need to define these 3 labels, right? I can just define 1 label there.
Okay, underlying functionality is same.
Correct. I'm just
Okay.
defining, at the head, and I'm not capable of holding those many labels. I can just replace with that binding seed. So basically, this gets used widely in, you have a manual SR policies. In SR ODN, you define your seed depth and everything, so it will automatically configure it, depends on your topology information.
So
Okay.
this will prevent the smaller platforms from running out of levels.
Correct. So that is why, binding seed used for the scaling purpose.
And only applicable on head end.
Correct. Correct.
Now it sounds
Clear? All right?
So one more question also. You said it only validates the next hop.
Huh.
So if one of my next hop is invalid or that traffic it doesn't exist,
Mm-hmm.
my SRT policy will still come up and traffic could get black hole later on or?
Okay. So, again, can you please repeat your question?
You said you validate only the first hop. You
Mhm.
said what is this the fixed side or adjacency side.
Mhm.
If one of my later values is incorrect,
Mhm.
that side doesn't exist anyway in the
Mhm.
network. But my SRT policy will still come up and traffic would reach that particular node and then get black hole there.
So see, that will come to know, once you have your next hop reachability is not there, that will come to know. And the SR policy, see, basically that is the disadvantage of having manual SR policies. That is why a customer is going for, your SR ODN, because you're really not sure, what is your next segment identifier.
So
All
let's say Rahul, in some 2-3 sites before you were having right that okay you can under particular preference you can decide that there are some 2-3 explicit paths and then
Mhm.
you can decide the percentage also.
Mm-hmm.
So let's say out of those 2-3 paths, one path is going down, but
Mm.
two are still up. So whatever percentage of traffic was supposed to go over that path,
Mm-hmm.
and going to
Obviously,
down,
it will switch.
it will switch.
Yeah,
So
yeah.
how it will get? That's what my question is.
Based on the
See.
ratio that you have.
Yeah.
No. Ratio is there, but that tunnel, we will get to know whether the tunnel is down. In MPLS, we will get to know the moment you will shut down each link and all, that
Mhm.
tunnel will go down. Here, we don't know whether, in policy, I will be defining the labels, right?
Mhm.
So I will be taking only the next hop. I will not be taking that, okay, somewhere down the network, whether that router is up or not, or that agency seed is up or not. Let's say that is going down.
Mhm.
So on the first router, hidden router, who is proportionately
First router, you will come to know that, see, whenever you are talking about this control plane, right, you knows that, your second hop is not reachable. Correct? You know that, right? Correct? That is the disadvantages of having manual SR policies. That is why customer is actually going via your SR ODN perspective, okay, which is completely automated. Okay?
There will be very few deployments of this manual because
Yeah.
somewhere in the network, always any router or link can go down or any agency can get deleted, right? So
Correct.
we never know.
So this is the other example where you have all the IP addresses. If you see here, the name of this SR segment list is 1018, which we had defined with all IP addresses. No, sorry, one mix of IP and labels. So if you see here, it is showing the last as also prefix it. So it is actually decoding the label value from your IP address. Okay. And again, the banding seed is different. If you see here, both the banding seeds are different.
Does it change with reload?
Yes.
Every time the policy comes in, it will get a new label.
Correct.
Then these.
Manu, that is again, having.
No. If you represent using IP is going to be same after reload. And we can get the new label which are.
No, if you are defining the node seed, you don't have any problem. Node seed doesn't get changed, right?
No, even adjacency set, if you are giving the link IP, there will be a corresponding
Correct.
adjacency set. Even if it changes after the reload, ISAs will redistribute it again based on the command.
Correct. Link sets.
So then we don't have the black coding issue.
No.
No, but SR policy will be configured with that particular link, right? And
You can define the loopback address. What he is saying, adjacency state, if it is getting changed, okay, you can define that with a loopback address having link state configuration. So it will derive your state adjacency state for that, and it can, your policy will stays up. There will be no problem with that. All right. So we'll talk about XR transport controller here. This is the main focused area of our presentation today. So XTC is completely, the use case of this XTC is multi-domain. When you have multiple IGP instance and you need end-to-end services of, L2 VPN, L3 VPN, or eVPN services, then in that case, XTC is widely used. Okay, so this XTC functionality is available in all iOS XR platforms, as well as, you have a virtual routers like XRV9K. It is available with all the images. Okay. And as I mentioned, the main advantage of having XTC is in the multiple domain, multiple IGP instance. Then you have to enable you link state, distribute link state under IGP and the BGP. Okay, BGP you have address family link state, the new NLRI, which actually get the information about the topology from the IGP. I'll define that later when we go through the presentation. The stateful, actually once you have a control of SR policies, once the PCC gives the control of that SR policy to the XTC, XTC can manipulate, the seed info whenever it is required. Let's say in between some router going down, okay? So it will send the update to the PCC, and then PCC, can steer the traffic over that new seed list, okay? So that is why it is stateful. SRPC will talk about when I have a discussion on PSEP, so we'll talk about that later, okay? And the XTC's deployment, the main, like XTC's deployment is same like RR. You have route reflector out of your data path, right? Data plane. So that way you have a XTC's deployment. You'll have route reflector, backup route reflector. That way you can have a XTC or backup XTC. Okay, you can have that way. Okay, we'll go more in detail on that part. Okay, so as I mentioned, this PCE functionality, XTC is nothing but your path computation element. Okay, that will be acting as your server, and the head end will be acting as path computation client. That will be your PCC. Okay, and this functionality is available on all XR boxes. Okay, you just have to enable, on the XTC PCE address, which will be your source address, IPv4. That will be used as your PCE address. Okay, when your path computation client is trying to communicate with PCE server. I'll define that later how that flow works. Okay. So the functionality can be enabled with just this single command, PCE IPv4, and then IP address of that loopback. Okay. Talking about the XTC reachability consideration, XTC is again like RR kind of deployment, right? You don't want to churn your XTC with your IGP or BGP updates, so that you can keep your XTC out of your domain, IGP domain. Okay. You can have that reachability with static routes. Okay, and in single domain you can have XTC directly coming under your IGP domain. Okay, so in reachability consideration, the preferred is static routing, and then you can have IGP if you are using a single domain. So the PSEP operation, if you see here, this is XTC. The PE1 and PE2 will be called as PCC, with this path computation client. You have PCE as server, path computation element server. And the communication between PCE and PCC will be based on the PSEP, which is Path Computation Element Protocol, which runs over TCP. Okay. So once the PCC, once we get the info, right, that you need to have a SR policy for these services. Okay. The PCC will initiate a path request to the PCE. Okay. And then PCE will compute the path. Okay, how it will compute the path, I'll explain later in this presentation. And then it will send that path reply with your seed list info to the PCC, which is your head end. Okay, and then you have path report. Once your SR policy is up, the state of that SR policy has to be maintained by XTC again, right? Because if changes are required, then the PCE can take control of it. So for that, you have to send a report to the PCE again. So that is what the path report is. Once a segment routing policy is up, PCC will send a report to the path computation element server. And then path update. If XTC feels that the path changes are required, that will be updated from the PCE to the PCC with this path update message. All right, so XTC, the main use case, as I mentioned earlier, it's multi-domain, okay? And XTC can learn about its own topology information either via IGP or via BGP, okay? If you have a single domain, the IGP link state, distribute link state should be enough. If you have BGP, then you need to get this information from the IGP and feed over the BGP. I'll explain that also in detail. Okay, considering this is a single domain, okay, considering this as a single domain, once you have this distribute link state configuration under your IGP, okay, the XTC will get all the topology information directly, okay, you no need to have a BGP there, okay. Talking about the multi-domain, if you see here, you have IGP domain 1, IGP domain 2. You can actually feed the topology information to the XTC two ways, okay. One is you can have in each domain 1 or 2 routers peering a BGP link state neighborship with directly XTC, okay. You have a ISI, other ISIs or OSPF, you have a distribute link state configured. So all this information is available in the this link state information or the topology information is available inside the IGP. Now you have BGP configured with the XTC, BGP link state, okay. So this will actually get this info from IGP and feed it to the XTC, okay, via BGP link state, okay. The other way, you can have a route reflector from each domain. You can have a neighborship, BGP LS neighborship with route reflector, and let route reflector feed that info to the HTC directly. Okay, there are two ways you can configure. You just have to enable address family link state under your BGP for this. Okay, is there any question here?
We don't need any
BGP.
and any ISI suggestions, right? Just reachability should be separate.
Yeah, no, you need to configure distribute link state in your IGP domain. Okay.
Yeah, but okay.
And you need a ISIS reachability or OSPF reachability with XTC also.
Okay. I thought.
Yeah, so that if you are keeping it opposite, keeping it outside of your IGP domain, then obviously you need a BGP LS there. Okay, if you are putting it generally in single domain, you no need to put BGP LS for feeding this info to the XTC. You can just feed it via IGP. Okay.
When we have two domains, that time we need BGP router.
Not necessary, you need a BGP route reflector, but that is how the customer deploy their network, right?
But you can have the XTC part of both the domains and it should also work, right?
Correct, yeah. So XTC will be the centralized device, right? It can actually get the info from one IGP instance, other IGP instance, multiple IGP instance, for example. All right?
So the same functionality I can achieve by even redistributing the IGP instance, let's say OSPF into ISI into OSPF, then I don't need this BGP router to communicate all the different XTC.
No, but in that case, you are actually, see, the main purpose of this is to get the seed info, right? So that will be derived from the link state. Okay, for that reason, we need a link state, correct? Because we have the capability in the IGP, you know, to get those topology information. When I say topology, it's node seed, or you have state of the link or everything, right? So that can be carried over this link state. So that is what I'm referring as a topology.
What I'm saying is, let's say in a single domain, we were not in need of this router vector to communicate with it.
No, not required.
So let's say even if we are having two domains, and if I'm redistributing the IGP instance of one into another, then I think the same functionality we can achieve without router vector.
In that case, see, okay, I got your question. You mean like you have two domains, you're doing a redistribution, then you don't need a route reflector. That's fine, but you know, the actual production deployment is like that.
Okay.
You can just go with route reflector or without route reflector, having directly BGP LS peering with XTC. Those are two options, you can choose anyone. Okay, so just now I have explained you, right? I wanted to get into the details here. So let's say this is one IGP domain and the other IGP domain. You are running link state under IGP. You have that link state information in all the routers. Okay. Now you have route reflectors and XTC. Okay. So how you will feed that info to the XTC? Okay. You will have like from one domain you can have at least two routers which will having a BGP link state neighborship with route reflector, correct? And then inter route reflectors for the updates, and then you can feed that info to the XTC via BGP link state. All right, got it? Okay. Once the XTC have this info, XTC can visualize, you know, the entire topology. By deriving the entire topology, it can actually, if you see here, it can see the entire domain 1, domain 2, or domain 3, whatever you have. It can actually visualize everything. It has all the infos. Okay. If you put that link state information in some GUI, right? XTC team has those GUI. You can see the complete network diagram with just that link state information. Okay. See, for them it can be some PCE server. For us, it's Extra Transport Controller. We named it as XTC, right? It can be any PCE server for them. Okay, for them it is requires a Spark Computation Element Server. That's it. Yeah. Protocol is RFC, PCEP. That can be used. Even earlier in like MPLS traffic engineering, we use this PCE, PCC, right? It's the same thing, right? Huh? I'm not sure which customer is using, but there was a RFC PCE for MPLS traffic engineering also. All right. Okay.
So if the headend is not having a direct connection with the XTC controller, right? Headend is distributed.
Not necessary. Not necessary.
So in that case, if the XTC controller wants to push a policy to headend, how will it achieve that?
You have a PCEP, right? It's a TCP based.
Okay, I define the IP address there.
Correct.
A direct connection means I need to have a peer defined in all of my routers, right?
Not necessary. You see, suppose for example, how you have a route reflector deployment, right? The same way, you can have at least 2 routers or.
Okay, yeah.
Yeah, that means like if from each domain, just have 2 routers for the HA purpose, high availability purpose. You can have just 2 routers peering with the XTC. That should be enough.
Typically, we use RR and XTC as the same box or different?
It should be different ideally. That is what the deployment use case is, because you cannot put all the load on one device, right? So
but
it's always
virtual device, and that's the better solution.
Yeah, XRV 9K we can use it. Yeah, that is how actually the deployment in deployment actually we are using it.
One of the head nodes can also act as an XTC.
Yeah, but yeah, for testing purpose obviously we can do that, but.
Can you go back to the one slide back? So here. So let's say that okay, my router 1 is going to be my head node of a policy. So how XTC is going to communicate that to R1?
Okay. So for that reason, you have a path computation. It will be called as path computation client. Okay. Under head end, you will define under segment routing traffic engineering. You'll define the PCC. Okay. You will define yourself as a PCC, and you'll define there the PCE address. Then only the PCEP session will start. You'll have to define the peer as a PCE, and even you can define the multiple PCEs.
Eventually, any of my head end router
will have a direct configuration of PCE IP, so that the PCEP session will start there. All right. So before we go over the other things, there are few things which have to taken care, while configuring this. One thing is, let's say you have a multiple instance, okay? Then this BGP link state feed is going directly to XTC. Just to differentiate that, you have to define the instance ID under your IGP. Okay? Let's say you are border router, you are running 2 instances. You have to define the 2 instance ID, 2 different instance ID, so that differentiation can be there. Which domain is like from which domain you are getting this topology information. So that can be defined just adding an instance on your distribute link instance. You can define that instance ID. Okay, so by default, that instance ID is 0. You have that ranges for ISS and OSPF. You can use that. 1 to 31 is actually, we should not use it. Okay, the other thing is, once you have these multi-domain, you are the border router. If you see here the BR1 showing up, you are running multiple IGP instance. You should have a same TE-ID configured on both the instances. Let's say loopback 0, then you should be enabled both the loopbacks, like both the multiple instance with the same loopback ID as a TE-ID. Okay. The other one is you have a BGP and you have a IGP, then you should use your T router ID and the router ID of your BGP should be same. Okay? Prefix? No, that is because you are defining the node seed, right? You have to maintain that.
But across two domains.
Yeah, because you are defining same loopback as your prefix.
These will be two different domains.
Yeah, two different, but it will have the same node seed. Okay, the high availability of XTC, it will be like you're same as route reflector, like you have active route reflector and the backup route reflector. Okay, so head and sends PSAP reports to all SR for all SR policies to all connected XTCs. Okay, so let's say you have two XTCs, you will be sending this PSAP report to both the XTCs. Okay. Once you in PCC you have a option to configure the preference for the XTC. Let's say I wanted to define a preference to XTC1, I can just define the preference, okay, in the configuration, so that I prefer that XTC for my SR policies, okay. So once you prefer that, this delegate flag will be set to 1 for the primary XTC, okay. For the secondary XTC, it will set to 0, okay.
We get the path from both and it will prefer the first path.
Correct.
But both.
No, both will not see. As I mentioned, right, in that PSAP sessions, once you have the PCs, once you have a policy up, okay, you send a path report, okay. Path report, you will send it to only your primary XTC, okay. Once that goes down, you will send it to the secondary XTC, okay. So upon failure of primary XTC, head and redelegates the control over another XTC. So I'll define that how it is done. Come again?
So once the primary goes down, secondary once again you need to.
I'm actually defining that here. Yeah.
There will be traffic drop for the primary.
No, because your SR policy is not going down, right? The PSAP session is going down. Okay. I'll explain this, then you'll be clear. So let's say you have this. Okay. You have XTC1 here, XTC2 here. Okay. Now, node 1 requests XTC1 to compute the path for node 3 here. Okay. XTC computes the path having a link state information, topology information, and it actually sends the seed list 30102 and 30203 to your node 1. Okay. Then node 1 will activate your SR policy. Okay. Now your SR policy is up. Okay. And then, as I mentioned, as soon as the SR policy is up, it will delegate control of that SR policy to your primary XTC. If you see here, the D flag, delegate flag is set to 1 for primary XTC and D is equal to 0 for the secondary XTC. So it will send it to the primary XTC. Alright. Now XTC1 fails. Okay. Node 1 detects that my PSAP session goes down. It will start the redelegation timer. Once it is expired, then it will actually delegate the SR policy to XTC2. Okay. And then XTC2 will recompute the path again. It will check if it is, whatever the SR policy having this segment list is need change, then it will again, update the PCC or the head end that, you need to change the path. At that time, you can expect the traffic drop. Okay. Path disjointness. So basically, this is one constraint which we are going to talk about in SR policy here. So path disjointness is basically you have a guarantee service end to end. What you're doing here, you want your SR policy to not share the common resources. Let's say you have a 2 SR policy from one source to the destination. You don't want that both the policies should use the common resources. When I say that common resources, it can be your node, it can be your common link, it can be your SRLG group. Okay, the same fiber going under SRLG group. You can define that way those constraint under SR policy so that the XTC will compute the path. Okay, depends on your requirement. Let's say you are defined the node. two SR policies will not cross a same node. Okay, the seed list will be completely different from head end to endpoint. Got it? So it can be defined for two policies between same node, or it can be defined for, let's say you have two different policies on two different routers. Okay. So different level of disjointness, the link disjointness. Okay, as I mentioned, the path transit different links. It should not use a common link. Okay. Then you have a node disjointness, which will actually, make sure that both the paths are not crossing the same node. You have SRLG disjointness, where you don't want your path to cross your same SRLG group. Okay. And you have node plus SRLG. Okay. So node and plus SRLG. Okay. The common head end and the endpoints nodes are not taken into account of node disjoint. It may take the same node if you have common source and destination. So you should avoid defining this constraint there. Okay. Now the path disjointness level fallback. Okay. What if, I have defined the constraint that I want that these policies should not go as same node. If that policy is not getting, if that constraint is not getting qualified, what will happen? It should fall back, okay, to the next available. Okay. So you have this fallback mechanism here. If you don't have node plus SRLG qualification, then you will fall back to the node. Okay. If you don't have node and link, then you will fall back to the link. Okay. It will not cross the same link. If you don't have link also, in that case, it will go with the IGPs. Okay. So that is what I have defined here. Okay. If no node plus SRLG disjoint path available, then compute node disjoint path. If you don't have SRLG or node disjoint path available, then compute the link disjoint path. Okay. And if no link disjoint is available, then go for the shortest path. All right.
Explicit path as a backup, like the primary has given all the seeds and computed the path. And if that goes on again, XCC will compute the next path, right? So that can it push a explicit path?
I'm not getting your question. Can you please repeat?
So if there are three nodes, and it has computed the primary path, it will push all the labels and.
Okay, just to tell you that it will always have only one path. It will not have multiple paths.
So when it goes down, like it again computes.
What goes down?
When the primary.
Okay, when you say the path is going down, okay.
So it computes a new path, right?
Correct.
There can we push a explicit path, like.
No, see, what happens here is actually once your first path, whatever is seed list, you have got it right. Once you see that, node is going down, your FRR will kick in. TILFA will take care of that. Till the time the next BGP link state update is reaching to XCC of topology changes, and then you will push the new policy seed list to the head end. Till that time, it will go via our TILFA FRR.
So when it computes the secondary next path, right, then can we give it as explicit path, push it from the XCC? Is it possible?
No. You cannot. It's all dynamic.
It's all done.
It's all dynamic.
Once the first path is computed and you don't want the second path to be on the same node or same link or anything. Okay.
You mean second path means two different SR policies. There will be only single path for SR policies. There will be no two different paths. So let's say I'm talking about here two different SR policies.
Right.
Okay, they don't want to share same resources.
Right. So the first is already computed. I mean, the request comes for two.
Okay, got your question, yeah.
Will it recalculate the first?
Correct. It will recalculate again. I have defined that also. Okay, so now it is very easy, when you have a same source and same destination, you can just define, the two policies should take a different path. Okay, but it actually create a problem when you have a multiple routers. Let's say router 1 to router 2 and router 3 to router 4. You have two different policies on two different routers, and you'd want they should not share the same common resources. In that case, you have to use association group. So this is a mandatory configuration if you are looking for disjoint constraint, disjoint path constraint, right? So XTC will see that association group is configured, and it will see that you need no disjoint path. Okay, then it will actually start computing two different paths for these two policies. Okay. So that is where the association group is being used. Okay. If you see here in disjoint configuration, if once you have this template ready, you have here association group, and the type can be anything like node, link, SRLG plus node. Okay. So you are defining this group ID same across two policies where you need the disjoint path. Okay. So we have a limitation here. We can have two policies under one association group. Okay. That is the maximum. Okay. So how it works? Okay. You have this topology. There are two node disjoint paths are required from node 1 to node 4 and node 5 to node 8. Okay. Now what happened? Node 1 first requests the path to node 4. XDC computes the path and replies with the seed list. Okay. Now node 1 installs the path and reports to the XDC that SR policy is up. Okay. And delegate control to the XDC. Okay. Now what happens? Everything is up for node 1, and then node 5 requests path to node 8. Okay. And XDC sees that, it is coming with the same association group, and they both needs to answer your question. Both needs are two different paths. Okay. Then XDC will compute the path and it sees that, the first path need a changes. Okay. It will update the node 1 that, follow this seed list. Okay. And then the first SR policy will take a different path.
But some other constraint, if it's not meeting, then what will happen?
It will fall back. It will fall back. Okay. And then you have again XDC sends reply to node 5 for the seed list, and both the policies are taking two different paths. Clear?
In define affinity, etc.
Affinity, I don't think that the support is still available there. You have it in manual SR policy. I'm not sure about the SR ODM. I'll check and get back to you. As far as I know, this support is not there. Okay. Oh, I'll do one thing. I'll send you, because I forgot to put that affinity constraint configuration here. I'll put that and give it to you. Okay. Okay. So disjoint path workflow. Okay. If there are topology changes, okay, the BGP link state will update the topology changes to XDC, and XDC will recompute the path and update to the PCC. Okay. Now the on-demand SR policies. Okay. So we have time, right? Okay. So for this on-demand SR policy, we have to use the same kind of setup. Okay. Whatever we discussed about the XDC till now, right? So we have to use same thing. Okay. So in on-demand SR policy, you just have to define the template on your head end, which will contain your color and then the endpoint. Okay. And if you need any disjoint constraints like disjoint path or node level or link level, okay, that can be defined. Okay. So I'll just take the reference of this diagram and then I'll explain you. All right, you have a multi-domain here, right? So what you're expecting is either your eVPN services or your L3 VPN services to go over SRT policies, right? For that, what you have to do is you have to set the color. Okay, you have the configuration on the head end PCC for the template configuration for policy, and then you have to set that extended community under your BGP updates so that it will set up the color. Okay. That can be done with the two ways. Either the endpoint is setting up the color and updating the route reflector while sending the updates, or is you are the head end, you are accepting those updates and you are setting up the extended community there. Okay. There are two ways inbound. Okay. On the endpoint, you can actually send the update and set the extended community, and while getting into your head end, you can set the extended community and get the updates with the extended community, which will be color. Okay.
Under VRF also you can define it. Under BGP.
Under VPN v4 you can define, right? VRF it is.
Under VRF also I think you can do. Under BGP. VRF content.
Okay, but the main use case is for L3 VPN, right? So you can define under VPN v4. You just have to match your prefix set,
Okay.
or you
So one customer, if you want to put one color, so that
you can define the RD.
Okay.
That is better, right? I hope everyone is able to follow till now, because this is the main thing now I'm going to explain. All right. So setting up the on-demand SR policies. So see, what I'm doing here is I'm giving configuration template of eVPN services, and I'm giving example like the pictorial view, right, for the L3 VPN services. So both the things can be cleared. Okay. So what we have to do is we have to set up the color for on-demand paths. Okay. That is a step one. Okay. That is nothing but your extended community. You're setting up the extended community. What you're doing here is you're giving the color name and then what color you needed. Okay, that can be any number, whatever you have. Okay, you're setting up the extended community here. The step 2 is match eVPN VPWS services using RD values. You have a RD set. Okay, so what you are doing under RD set, you are matching your RDs. Okay, and assign the color to that eVPN VPWS session. How can it be done? So under route policy, you are referring this RD set. If RD in this path, the RD set name, then set the extended community. So let's say you are defining extended community here as 1001, okay, and you have RD, let's say 10.111:1001, okay. What you're doing is you're defining a route policy. If RD is 1111:1001, then set the color 1001. Got it? Okay, and then apply this color to the services. Either you can apply these services on the outbound for the endpoint, as I mentioned earlier, or on the head end while that update coming from the route reflector. Okay, you can define both way. Okay, so again, we have a limitation here with 500 matches, right? So you can set 500 on the outbound, 500 on the inbound, so that you can get 1000 SRT policies up. Okay. Okay. So for SR policy, you can define so by default when you say SR policy use metric type T. Okay, but you can define here if you want metric type IGP or metric type T. Okay. So when you say metric type T is low latency path, right? So this is what the template you have to define on the head end. Okay. So now I'm taking the example of L3 VPN here. In this case, let's say the C1, okay, is advertising 20/8. Okay, the L3 VPN service is from 1 to 3. Okay, let's say. Okay, and this BGP route update is updated to the router 3. That 20/8 is reachable via the C. You are updating the SR. Okay, here what you're doing, you are setting up the extended community color on the updates going towards route reflector. Okay, if you see here, I'm actually setting up the extended community here, color 10. Okay, so updates are going with your extended community. Okay, those updates will reach to your router 1 with the color.
What is the best effort?
Best effort is actually they wanted to go with the metric type IGP. Okay. Once you have this, XCC will see, the head end will see that the updates are coming with the color 10. Do we have any kind of template configured on our router with color 10? Okay, so it checks that we have a template configured, and we need to reach XTC for getting the seed list info. Okay, once we have it, then P1 will ask XTC that I wanted to reach P3 with the lowest IGP metric. Okay, XTC will compute the path and provide the seed list to the router 1. Okay, then your traffic will start flowing with that. So the traffic will push to your binding set. If you see here, this binding set is 4002 here. Okay, and that will contain your 16,002 and 16,003. Okay, so now your L3 VPN services or the route, like the traffic which is going to the 20/8 will use your banding set 4002. Okay, that will be your SR policy. Okay, the services is going over SRT policy now. Okay, now let's say your requirement is low latency, metric type T. Okay, the same way you get the update with color 20, you'll see the template, you'll ask XTC for the lowest T metric. Okay, it will give you the seed list and the traffic will flow. It will push to the binding state 4001. Clear? Clear? All right. So we have few use cases from the customer. I hope everyone is clear, then I'll go with the use cases. Folks on the bridge, everyone is clear about this? All right, then I'll go over the use cases from the customer. I have only 4 slides to cover, the 4 use cases are there. I'll just cover those and we'll be done with the session. Complete SR? I'm really not sure about that, which is the customer which used, yeah. Yeah, so SoftBank and Colt started deploying together. So I'm not sure we are not sure who, yeah, okay. All right, so this is one disjoint path use case 1. This use case was there for the Sky and Colt as well. Okay, you have a 2E VPN VPW services. So let's say node disjoint. So they don't want the services to use a common resource as a node. Okay, that one was a use case. It was a use case for AIS as well, but in case of AIS and Colt and Sky, the difference was for each and every EVPN VPW services they were having a single policy. Okay, so for each EVPN VPW services there were different policies. Okay, SR policies. In case of AIS, they had 4,000 EVPN VPW session, and each 4 EVPN VPW session were using a single policy. Because the limitations are we support only 1,000 policies. All right. The other use case is from the same routers, 2 EVPN VPWs going to the same endpoints, and I need a disjoint path services there. All right. The second use case is with ASR 9K deployment, wherein we need EVPN VPW sessions terminating on pseudowire headend, and then between those you need path disjointness. All right. The third use case is from the Vodafone, where they are using a multiple IGP instances. Okay. For each IGP instances, they have a route reflector. Okay. So in that case, you are getting update from each IGP domain to each route reflector, and then it is going towards the XTC. It's the same kind of deployment which we talked about in multi-domain services. All right. Is there any question? Because I'm done with the presentation. So just to update, I have written a white paper on segment routing, traffic engineering, and segment routing OD and policies, right? I will be sharing along with this presentation. That is, it is giving a good idea about step by step how you can configure the SR policy or you can configure the XTCs. So you can go through that. You'll get more details. If you have any question, you can send me email. Huh? XR? XR.
Delay measurement.
Yeah.
Any details on those, how it is done?
We can do one thing. We can set up one more session wherein we can actually discuss about this flex algo. We can discuss about this way NSO use cases. that time we can actually discuss about this also. That can be done.
So here it is automatically, so the disadvantage of T is like you have to define what is there in the link. Every link you have to define. So here it is not automatically calculated.
So the the other way is you can define the loopback addresses. That will be useful, just define distribute link state and the loopback addresses,
Right.
so that you don't have to worry about
Reachability
part. So your SR tunnels will be up and your traffic will not black hole. All right. Can I stop?
Yeah, thanks.
So what is the maximum label depth for 9K? I heard somewhere it's